recorded high voltage system. So if we consider for the first one on the work permit, the work permit has to be classified for a certain category. The first category which can be considered for a risk factor. That means dead working, live working, working in vicinity of live pods. Number one is nothing but dead working. Number two is nothing but live working. Number three is nothing but work in vicinity of live pods. So your first one is the working in vicinity of live pods. Working in the vicinity of live pods is nothing but all work activity in which the worker enters the vicinity of live zone has to be in that body. That means the concept of dead working. The dead working is nothing but it's a very, very dangerous one because we are handling for the high voltages. The voltage value is directly proportional type of insulation used. If the voltage will has to be step up operation performed simultaneously, the high voltage insulation can be operated. Otherwise, we can observe for the shocking effect. The second one is nothing but general information permit to work. That means you are all engineers. By based on what criteria you have to work on the permit. That means your first criteria should be considered for unauthorized or a responsible systems. Second one, it can be valid for only 24 hours. So within the 24 hours, you can complete for all the works and then you will be reported for what is the problem or what is the problem criteria on your system. Your second one is nothing but permit to work. That means board on guidelines. So permit to work board on guidelines is to be considered for a carbon copy duplicate has to be attested and the 5 sections. So your first one will be considered for first section and then second section, third section. The insulation resistance test to be considered for and high voltage equipments. What are the insulation you are using? That insulation can be operated for high voltage levels. So these insulations are having a certain resistivity. That resistivity we can to check as well as verify. By based on the insulation resistance only, you can operate for the system or you can operate for the system models. So that we can operate for the first one is the polarization of index. The polarization of index is very important because the PI value or the ratio between IR value recorded after the application of the test voltage level. The test voltage level can be considered for continuously for 10 minutes. The value recorded for after 1 minute of application. So the PA, that means the power as well as the current value will be considered for 2 or more. It should be considered for under the category of satisfactory. So the current as well as the power value should be measured as well as it can be maintained for within the prescribed range. Next one, safety testing of high voltage equipments. The high voltage equipments, how you can to be tested. That means the safety operation, how you can perform. So the safety is very, very important. In this safety, we are having a typical layout of a propulsion system. That means the development of high voltage shore on connection. It is simply mentioned for HVSC. High voltage shore on connection. The high voltage shore on connection should be very, very simplest one. That means you are having a ship as well as shore. How the electricity should be transferred from ship to the shore. It can be considered, or from a shore to the ship, how the electricity should be transferred. So this high voltage they are considered for 1 kV AC to 15 kV AC. That means 1 kilovolt alternating current to the 15 kilovolt alternating current system. So in this consideration, the cable management system is to be important one. Before that, electrical system having a ground philosophy. Grounding, the grounding of electricity is very important. Grounding, because may you know the concept of grounding is nothing but the unwanted current is flowing through the circuit. That current will be called as that current is called as the leakage current, the unwanted circulating current. If your system will become a balanced one, generally the electrical system can be classified for balanced system as well as the unbalanced system. If we consider for the balanced system, the power value will be at all the lines should be uniformly shared. So the IR plus IY plus IB, if you consider for the namely three-phase system RYB, if you consider for the balanced system, the neutral reaches for zero current. The IR, IY, IB, all the line current should be equal. If we consider for the unbalanced system, the current value is not equal. That means the neutral will absorb for certain flow of a current. If you consider for the leakage current is something, but a system is to be under the consideration of unbalanced level. The neutral absorb for the unwanted shocking current. So this current will be immediately grounded. If this current is circulated on the outermost body of the material or the outermost frame. So this is called as the leakage current or unwanted circulating current in the network. This current will be immediately grounded because we are free from the shocking effect. Second one is nothing but cable management system. In the cable management system, how the cables ought to be designed. So the cable having an insulation. This insulation strength or the dielectric strength is directly proportional to the type of insulation which you are considered. For example, if you consider for the solid insulating material, we are using for porcelain insulator. The porcelain insulator having a highest value of insulating capacity. So this porcelain insulating material used for the highest value of dielectric strength. This insulating material having a flexible of high voltage cables. With the plugs exit to the shore of power system, repeatable. Cable reel, automatic tension of control system with associated control gears and instrumentation. Shore power is fed to the shore connection with the switchboard using the cable management system. This is the comparison of your cable management system. Next one is nothing but shore connection switchboard. The shore connection switchboard is very, very essential one. Because if you consider for the shore connection, the power is connected to the shore. The high voltage shore is power is connected. The shore connection between switchboard by means of the high voltage plug and the socket arrangement. The shore connection of a switchboard can be provided at the shore power connecting circuit breaker through the protection of your devices. So this operation can be considered for HVAC installation is sufficiently rated to the supply of some arrangements. That is the normal service required in the port, emergency service required in the port, service needed to support the ship operations in port. So by based on these three considerations, this operation is performed. Number one is the system grounding compatibility. The system grounding is very important because if the system is grounded, there is no way the leakage current is flowing from shore to the ship. So the leakage current is immediately grounded. The system operation will be negligible. Usually you having a shore section, high voltage transformer. This high voltage transformer having a capacity of 6.6 kilovolt, and then you having a neutral ground resistor, and then equipotential bounding. The second section you having a step down transformer with a rating of a 440 volt. The ship side you having a step down transformer. The shore side you having a high voltage secondary 6.6 kV systems. So this system can be operated for from shore side to the step down transformer side. So the step down transformer is located on a ship side. The shore side you having a high voltage transformer under the category of 6.6 kilovolt. The operation is very simple. If the power is transferred from shore to the step down transformer, this step down transformer operation in a variable 3-phase 5-wire system. The 3-phase 5-wire system can be operated for under the range of a 6.6 kilovolt to 400 voltage or 440 voltages. This 440 voltages connected to the ground system, automatically a system having a purely grounded. That means a step down transformer is grounded. We can observe for leakage current. If suppose any leakage current is flowing through the circuit, a transformer is the delta star or star delta connection. Obviously, we are using for a delta star combination because the load should be connected between any one of the line to neutral. So the load is connected between line to neutral. Definitely, here you having a neutral grounding resistor. The neutral grounding resistor will be connected to the ground circuit automatically any unwanted current is flowing through the circuit, this current will be eliminated. A second one, the neutral grounding resistor connected for equipotential bonding. Equipotential bonding is nothing but the neutral grounding resistor is connected to the shore side to the ship side. Ship side as well as shore side. Both are interconnected. If we having an interconnected media, automatically the two ground system operating on a ship. The 6.6 kV transformer in a primary side, that is the shore side. And then 6.6 kV same system operated for a ship side. So both the side we having a same operating voltage level. The neutral grounding resistor can be operated for in shore side as well as ship side. The system will be connected. Third one is nothing but the again systematic operation of shore side transformer under the operation of 6.6 kV. I am having a one of the isolation transformer. The isolation transformer winding ratio is 1:1. That means acting as a booster transformer. Already I mentioned for a booster transformer. So you know the concept of a transformer. It is the one of the electrical machine which transform electrical energy from one winding to another winding without any chemical change in power as well as frequency. Such a name of a machine is known as a transformer. Some textbook they are mentioned for a, it is one of the electrical static device. We can't say like that. It is one of the electrical static machine which transform the electrical energy from one winding to another winding. Here you having the operation of a booster transformer. The isolation transformer having a winding ratio is 1:1. The same operation of a booster transformer also. This is also having a same 1:1 winding ratio. That means isolated by shore side as well as ship side. This is the main purpose of this isolation transformer. The isolation transformer isolated for the healthy session as well as the faulty session when the fault is occurred because it is also grounded. And then the final one you have to consider for the neutral grounding resistor connected along with a switch. The high voltage transformer secondary side we are having a 6.6 kilovolt. It can be connected to the ship side also. So here in this side we are having a neutral grounding resistor. The neutral grounding resistor is to be disconnected. A system can be operated for under the unbalanced condition. If we are having a star connected system, this star connector system, the neutral line is disconnected means the voltage between VRN, VYN and then VBN is not equal. That means the unbalanced voltage between acting on VRN, VYN as well as VBN. So the neutral is properly connected with the resistor. So you having a one of the switch. When the switch is closed, the neutral line along with the resistor is connected to the ground system. So whenever you need for the grounding or equipotential bonding operation, you can closing the switch. Automatically the closing operation has to be performed in this network. Temporary parallel running is the one of the important one, where the shipboard generator is intended to run the parallel with the shore power of a short period. You are having a temporary parallel running of operations performed. That means we have to provide it for to verify the incoming voltage of a generator should be equivalent to outgoing buses of the generator. That means the shipboard generator can be adjusted with the automatic voltage regulator. So the shipboard generator operating for certain voltage level. The automatic voltage regulator is also operating for certain voltage level. It means to provide it to verify that incoming voltage of a system should be equivalent to the automatic voltage regulator. So how you can vary the voltage? By varying the field excitation of an alternator. If the field excitation is varied, the flux value varied. If the flux value varied, regarding to the concept of an EMF equation, if the flux is varied, means the voltage value is also boosted. So the parallel operation can be performed, the automatic voltage regulator along with the shipboard generator. So it can be mentioned in the first point. Second one, load transfer to the automatic. The load is transferred to the automatic. That means we having a certain speed governance mechanism. If the speed is increases, the load frequency value is also increases. So this operation can be depending upon LFC. The LFC stands for load frequency control. The load is varied directly proportional to frequency. The frequency value is also increases. If the load is increases, the frequency value increases. The previous section, automatic voltage regulator operation depending upon voltage. The second one, load transfer is to be automatic, means this operation to be depending upon the frequency variation. If the frequency is varied, the steam input varied, frequency varied. If the frequency varied, real power is also varied because it is to be interlinked one. So the every operation will be considered for certain bonding condition. The bonding condition is important. The concept is real power and then reactive power. Steam input varied. Steam input varied means automatically the frequency of a system varied. Steam input varied, frequency varied. Frequency varied, power angle varied. Power angle varied, the real power of a generator is also varied. The second one is nothing but the reactive power. Reactive power is to be depending upon the variation of field excitation. If the field excitation is varied, voltage varied. If the voltage is varied, means automatically reactive power can be varied because real power flows from higher power angle to lower power angle. Reactive power flows from higher voltage to the lower voltage levels. The second systematic operation will be considered for here. The switchboards are to be subjected to the AC withstand level. That means switchboards. Switchboards, the switching station or the switchboard is important. If I want to increase the load, means directly we can't connect the load to the source. Slowly, step by step, the voltage values to be minimized, then only the load is to be connected. It is the one of the good example for how the induction generator or the alternator is loaded. The alternator is to be started for with the help of a steam engine. The alternator is running for certain speed. By based on the condition, we can vary for the speed of the alternator to the rated speed level. Afterwards, we can increase for the field excitation. Then only we will connect that to the load. So the load is to be applied to the alternator or any generator, means the generator should be delivered for rated voltage with respect to the rated speed condition. Then only the load is to be connected. If the load is connected, automatically the generator connected to the load. The load is varied, the load current value increases, voltage value started to decreases. So in this today class, we have to observe for two important things. The first important thing is nothing but work permit, work procedures. Work procedures on the ship. The work procedures on the ship has to be depending upon live working and then dead working. The second one is nothing but work in vicinity of live wires. Work in vicinity of live wires is nothing but near to the adjustable parts. So the dead working, general information to the permit. General information is nothing but it can be valid for only 24 hours. And then permit to board of guidelines. Board of guidelines, you having a carbon copied duplicate at least of 5 reasons. First section says that nature of work. Second section consider for your declaration. Third one to be considered for danger section as well as signed person to receiving the permit. Fourth section to be considered for permit holder and the work has to be completed. Fifth section signed by the issuing authority or cancelling the permit. So this concept to be considered for on work permit. The final one you will be considered for insulation test on high voltage equipments. The insulation test otherwise called as the insulation resistant test on high voltage equipment. Here the high voltage equipment can be tested. Once the test is completed, after that only we have to consider for certain works. In this criteria, you have to consider for polarization index as well as safety testing. Safety testing will be considered for example, if you consider for a pin or suspension insulator, the pin insulator, the voltage value will be up to 11 kV. The suspension insulator, otherwise called as the disc insulator, the operating voltage level is also 11 kV to the 33 kV. The same suspension insulator, otherwise called as the string insulator. The string insulator is nothing but the insulator one over another one needs to be loaded depending upon the voltage value. For example, if you are traveling, you can see for the nearest transmission lines, this transmission line voltage value near to the 110 kV transmission line. Each and every single disc having a voltage value of 11 kV. So you having a coupling of 10 insulators. 10 insulators arranged for 1 over 1. This insulator having a automatically 110 kV of capacity. If suppose any one of the insulator is breakdown, means automatically the entire system will be collapsed. So the high voltage testing is very important. So this entire criteria will be considered on a work on permit. And then simultaneous will be considered for equipotential bonding, system grounding compatibility. System grounding concept will be considered for this mode. That means how many generators will be operated on a shore side, and then how it can be connected to the ship side with the concept of a neutral grounding resistor. You having a neutral grounding resistor mechanism, so the connection lines transferred without any leakage or without any short circuit current, the neutral line observed for zero of current flow. If suppose it is the unbalanced system, the load is not balanced uniformly, that means VRN, VYN and then VBN is not distributed for the uniform value of voltage level. Finally, the neutral line having a certain current flow. This current will be observed for the grounding circuit, because any unwanted circulating current or any unwanted leakage current is flowing to the body of the material, you will observe for heating effect. So this heating effect can be mentioned and then uniformly grounded. The next one is nothing but high voltage transformer on secondary side and then primary side. So the same secondary side 6.6 kV shore side used, as well as it can be connected to the 6.6 kV of a ship side. So you having a two transformers. The same transformer having a two mode of operation. One is 6.6 kV and then distribution for 440 kV, 440 voltages. The second one will be considered for 6.6 kV as well as the secondary side of your 6.6 kV connected to the load. Here also the neutral connected to the ground. The equipotential bonding operations to be performed. The same concept of if the neutral observed for any flowing of current, it can be immediately grounded. This concept of operation performed. Finally, you having operation with the connection of a isolation transformer. The isolation transformer having the operation of 1:1 winding ratio. This is the brief review about that. 1:1 winding ratio is nothing but the operation will be considered for a booster transformer. The booster transformer is the operation of 1:1 winding ratio. 1:1 means the same voltage only transferred from primary to secondary. But if the fault is occurred, primary section and then secondary section will be isolated. The same system can be extended for the operation of a impedance relay circuit. It is the advanced one, because if the open circuit fault means there is no any continuity of a power supply, the system is not reliable. But if you consider for it is the short circuit fault, what will be happen? The short circuit fault means automatically, keep it in your mind, voltage value started to decreases, current value started to increases. So the primary side impedance, secondary side impedance is not balanced each other. So if the impedance is not balanced, the impedance relay started to reacted. If the impedance relay started to energized or reacted, the respective contacts are changing the position. The isolation of a transformer, that means primary to the secondary, will be automatically isolated. There is no any voltage transformation between primary to secondary. So this is the operation which can be considered for in this type of a circuit. And then your final one is nothing but temporary parallel running. Temporary parallel running is nothing but again the same concept. How the voltage is connected for parallel operation. Generally, the parallel operation will be considered for three methods: dark lamp method, bright lamp method, and then synchronoscope method. So the dark lamp method, when the lamp is completely dark condition, the switch can be closed. If you consider for the bright lamp method, same, if the lamp is under full illuminating condition, the switch can be closed. Finally, having a synchronoscope method. the synchroscope method, otherwise called as the 12 o'clock position method. In this method, whenever the primary or the incoming alternator and then outgoing alternator having a same value of voltage level, so the bus bar voltage will be neutralized, the switch will be closed. That means the synchroscope switch under the synchroscope, otherwise called the synchroscope needle, and the 12 o'clock position, the switch can be connected to the infinite bus bar. The second one will be considered for load transfer is to be automatic by means of a provided to the automatic synchronization. These points will be considered on the same as per norms. And then finally having a earthing mode of operations. So these are the constraints will be considered for the clearance of minimum value with respect to the normal voltage level. So 3 to 3.3 kV, we are having a clearance of 55 or 2.2 mm. Second one, 6 to 6.6 kV, 90 within the bracket 3.6 mm. So 10 to 11 means automatically 120 mm. So these are the different value of the clearance which can be used on the ships. So as per your syllabus norms, all the topics are completed. So what are the topics I completed? I simply mail it to your beme217@gmail.com. So that email group, I will message or I will mail for all the copies of the documents. So I wish you all the best for your examination. Take care of your health also. Bye.